All right, welcome. In this video, we're going to be talking about ellipse. So we're on 10.1, we're talking about ellipses or ellipse. And first of all, I just wanted to point out this picture they have of how we get the shapes of conic sections by cutting through a cone. This is what I was trying to explain in the intro video. So hopefully maybe if my explanation didn't make sense to you, maybe these pictures will. But anyway, these are just how you would cut the cones for the different shapes, but they don't have circle on here. But again, that would just be if you cut it through flat instead of slanted. Anyway, so interesting thing about ellipses. So ellipses are really cool. Basically, let me find a picture. Ellipses have these things called foci, or so the singular would be focus, plural would be foci. I've also heard it said foci, but I prefer foci, so that's what I'm going to be saying. And basically, these foci have interesting properties. If you have something that's elliptical in shape and you pass something through one of the foci. So like say I had a table, say this was a table with like a wall, like a pool table, but so imagine a pool table, but but in an ellipse. So there are walls around the edges in the shape of an ellipse. And I pass a ball through the focus, it's going to bounce off the edge and it's going to go through the other focus every time. And then it will bounce off the edge and it will go through the other focus and it'll bounce off the edge and it'll go through the other focus until it runs out of steam, basically. But it doesn't just work with balls, it works with sound waves as well. So if I have a room that is shaped like an ellipse, so that's what they're showing here. If I have a room that is shaped like an ellipse and I stand at a particular spot, in other words, if I stand at the focus so that my voice is going through the focus and then bouncing off the ellipse and then going through the other focus and then bouncing. So if I'm standing so that my voice is going through the focus, then I can speak really, really softly. I can whisper and you'll be able to hear me really easily because I'm standing at the focus. So that's what's called a whisper chamber. Also, at our school, if you're in the lobby is elliptical in shape. If you're in the lobby, there's a tile you can stand on in the middle of the lobby. It's kind of right in front of the couch where your voice gets all echoey. And so that echo effect is because you're standing at the focus of an ellipse. So you get that weird echo, and it sounds really weird, right? It sounds really weird when you're standing there and talking, like you feel like your voice is like vibrating. It's because you're standing at a focus of an ellipse. So ellipses, super interesting. They have a lot of application because of how that works with the foci and how of things passing through the foci. So interesting stuff with ellipses. I think ellipses are super cool. Circles, which we talked about earlier this week, are basically just an ellipse where the foci have gotten to the same point. So basically, the more circular an ellipse becomes, the closer the foci are going to be to the center. So when it's a perfect circle, they both meet in the center. So the circle is kind of a specific example of an ellipse. The ellipse is more general, kind of like a square is a specific type of rectangle. It's kind of like that. So a circle is a specific type of ellipse. Okay, so let's actually talk about ellipse now that I'm done geeking out. Right. So the parts of an ellipse, let's do that first. Parts of an ellipse. You have the vertices are going to be the furthest point in the long direction. Okay, so you have vertex at each end, and the line that goes through the two vertices is called the major axis. So that's going to be your long axis, major axis. The minor axis is perpendicular, right? Center. Minor axis is going to connect to the co-vertices. So the co-vertices don't really look like vertices, but they kind of are, because they're the point furthest away from the center in that direction, perpendicular to each of the vertices. So these are called the co-vertices, and they're connected by the minor axis. So you have a major axis and a minor axis, vertices, co-vertices. And then the foci are always going to be on the major axis. So they're always going to be on the major axis. And we'll talk about how we find them later, but I just want to talk about a little vocabulary with ellipses before we do that. Ellipses, if you have, so this is showing like you could draw an ellipse by having a piece of string connected to the two foci, and then pulling it taut and drawing around. So basically what this is saying is the distance, the ellipse, the distance from the foci to the ellipse, if you add the two distances together, it's always going to be equal. So if I have, let's call this focus 1, this focus 2. The distance from focus 1 to the ellipse plus the distance from focus 2 to the ellipse is always going to be equal. So as I'm going around, right, those two distances are going to change, but their sum is always going to be the same. So their sum is always going to be the same, which is very interesting how that works. So that is that. Yeah. So that's kind of how we define an ellipse. And then these are kind of the pieces that we're going to be using. And this shows kind of that same thing, this distance 1 and distance 2. If I add those together, I'm always going to get the same thing. And then your book has a derivation of the formula for an ellipse. I'm not going to go through that. If you want, that's fine. But I want to talk about the formula. So this is the standard form of an equation for an ellipse. This one's specifically centered at 0, 0. So this a squared here is the distance from the center to the major axis. Yeah. Is the distance from, so a, not a squared, but if you take square root of that, a is the distance from the center to the vertex. So it's half the major axis is what I was trying to say. It's half the major axis. And then b is half the minor axis. So you know which direction to go. So you can have either version. You can have a being under x and b being under y, or b being under x and a being under y. So a is defined as half the major axis and b is half the minor axis, but a doesn't always go under x and b doesn't always go under y. It could be either way. And if a is under x, you have this situation where the vertices are along the x-axis. So the major axis is going to be parallel with the x-axis. And then if b is under x, in other words, if a is under y, then our major axis is going to be parallel to our y-axis. So it's going to be longer in the y direction. So basically, I'll talk about graphing this later, but basically what's under the x is how far you go in both directions from the center in the x direction, and whatever's under the y is how far you go up and down from the center. But whether that's the major or minor axis could change. I'll do examples and we'll see a little bit better, but that is basically how that works. Okay, so it turns out that there is a a Pythagorean relationship between A, B, and C. C, I haven't talked about that yet. C is the distance from the center to a focus. And again, it's always along the major axis. So if you have this situation, it would be up and down. This situation, it's right and left, but it's always along the major axis. And you have, again, this Pythagorean relationship because it turns out that this distance is A. This distance is A, and that has to do with the fact that I was talking about earlier about how the distance from the focus to the ellipse, if you add them together, it's always equal. That fact leads us to finding that A is in fact also this distance here. If you want to see me do that derivation, let me know and I will. But this video is getting too long already, so just let me know and I'll do that. But yeah, so this distance is A. So C then would be the leg of a right triangle. So we would get that A squared equals B squared plus C squared. So solving that for C, because that's most often what we use it for, is going to be A squared minus B squared. So that's the relationship that we're going to use. But it comes from, so you don't have to memorize it. Know it, but also kind of be able to think through it logically. It comes from this right triangle situation where A is the hypotenuse. If you remember that A is the hypotenuse, then figuring out this formula should be pretty easy. Okay, so that's all I'm going to talk about in this video, and we'll do more examples and stuff in the next video, but I wanted to get through kind of all of the main vocabulary and the setup for ellipses in this video, and then we'll do some examples. All right, hopefully that helps, and I will see you in the next video.